Hey everybody, welcome. Web2 Online is putting up a lecture series on chemistry, Chem 101. This is your well known and infamous Dr. Tra, and I have been given the daunting task of going through all of these lectures with you. Very detailed, very comprehensive, but at the same time, I'm going to keep it simple, I'm going to make it fun. And if you were able to go through this information and do exactly what I tell you, you are on your way to mastering basic chemistry. And these examinations, wherever you are around the world, GCO levels, CXE, CSEC, you name it, this is the blueprint. Right? So anyway, today we're doing a simple lecture on states of matter. And most of us are familiar with states of matter, solid, liquid, and gas, three phases. And we are also familiar with how to convert them: melting, freezing, boiling, condensing, and of course sublimation. Right? Um, Very important. There's a difference between boiling and evaporation. We're going to get into it later down in one or two other lectures, but just to make the point, boiling takes place at a fixed temperature for a pure solid or a pure substance, whereas evaporation actually takes place at any temperature. Right? Evaporation usually takes place at the surface of a liquid. Now again, we're going to go over it again. Right? There's a difference between boiling and evaporating. So evaporation can take place at any temperature, and it takes place at the surface of the liquid, where the molecules at the surface of the liquid get enough energy to enter into the gaseous state. Okay? But most important thing about these processes is that you need to know how to describe them using the kinetic theory of matter. Right? We'll look at the kinetic theory of matter a little later, but it's important to know, of course, the differences between the properties of solids, liquids, and gases, and to know how your solids, liquids, and gases, the particles are actually arranged in those states of matter, because it's important in describing it. So I just got two of them here to just guide you along the way how to describe all of them. Looking at melting, right? Now we're starting off with a solid state, and the particles are usually going to be in a fixed crystalline arrangement where they cannot move. They can have some amount of vibration, but they are in fixed positions. Once we add heat energy now, kinetic energy of the particles are going to increase, which means kinetic energy is energy of motion, as the particles are actually going to start vibrating even more. As we add more heat, the vibrations increase. Eventually, the bonds are going to break. When the bonds break, the particles now separate into clusters, and that's how they exist in the liquid state. So that's how we describe melting. The opposite, freezing, similar method. We're going to explain freezing the same way. Particles, of course, will start off in a liquid state, where, of course, as we just said, they're going to be in clusters. As we cool the substance down now, because we're going in the opposite way, we're going to remove heat, so the kinetic energy is actually going to decrease. The motion is going to decrease. The particles are going to move around a lot less. As they cool down even further, particles begin to stick together and start forming bonds. Once these bonds start forming, the clusters now merge into fixed arrangements, which is basically going to be the solid state. And so if you follow this general trend I've given you here, you can explain melting, freezing, boiling, sublimation, and condensation. Right? Really easy, just like that, simple as that. And it's important to be able to explain these processes in terms of the kinetic theory of matter. Right, so we talked about the properties of solid, liquid, and gases. This is important. This diagram, this table, really important, and to be familiar with it, because in all walks of life, in all parts of chemistry, it's going to be useful. Right? So this is the kinetic theory we talk about so much about states of matter. The state that matter basically is made of particles, and these particles, of course, are atoms, and they are in random motion colliding with each other and the walls of the container that hold them. Right? And there's a couple of experiments that we can use to actually support the particular theory of matter, and that's diffusion, osmosis, and as you see here, Brownian motion. Diffusion simply states particles move from an area where they're in high concentration to an area where they are in a low concentration. And so when we open that bottle of perfume, the particles of perfume gets out and it mixes with the air molecules, and eventually everywhere begins smelling of perfume. So that's diffusion. And it's very much explained in terms of gases and liquids, not so much solids. Osmosis is very similar to diffusion, but it involves water molecules. And so it's the movement of water molecules where water is in high concentration to where water molecules are going to be in lower concentration. And now we're moving across a selectively permeable membrane. So as you can see here, in the high sugar concentrated solution, the water molecules actually move in. So they're moving where water is in high concentration to where water actually is in lower concentration. Yeah? So it's more or less moving from a dilute solution into a concentrated solution. Brownian motion was discovered by Robert Brown, where he looked at the pollen grain under a microscope, and he saw the pollen grain moving around, and he concluded that it was the water molecules that were completely bombarding the pollen, and hence the reason for the motion. And it's called the Brownian motion. So these are three different examples that actually support the theory that matter with particles, right? And that's actually a wrap on states of matter. Simple, short, brief, and well, I can't get easier than that. But keep us on the loop. Let us know what's going on. Let us know what you want to learn. Give us an idea what challenges you may have. Maybe we can help. Subscribe, like us, upvote us, leave a comment. Look out for the other lectures because I'm going to be doing most of them, and I want to make sure you guys get this thing done real good. Okay, later, people. See you soon.